Okay, so the other type of two sample analysis that we might want to do is inference for a difference in means. And when we do this, we're going to approximate using a t-distribution. Again, there's a formula for the standard error if we were using R like a calculator, but we're going to use the convenience functions instead. So for this one, we're going to do a hypothesis test. And what I want to do now is see if the mean number of years of school that someone completed, I think that variable is, let's see, the highest year of school completed, is different between people born in the US and those born outside the US. So I think that was the variable born underscore in underscore US. Yeah, so that has two possible answers, yes or no. So let's write out our hypotheses. For this one, I think it's a little easier to do it in notation, but we'll do sentences because that's probably the very easiest. So the null is the mean number of years of school completed is the same between people born in the US and outside the US. And the alternative is the mean number of years of school completed is different between people born in the US and outside the US. Again, we put the boring thing with the equality in the null and the more interesting thing that might make headlines in the alternative. And we're going to start with our point estimate, our sample statistic, our observed statistic. And this is going to go back to the lab about quantitative variables, but it needs another step. So it's going to start off GSS, and then we're going to group by that categorical variable, and then you're going to do something that you know about, something from that lab about quantitative variables. And so I'd encourage you to pause the video here and see if you can figure out what that last line of code is. All right, I'm going to do it. So the way that we did summary statistics in that lab about quantitative variables is with the summarize command. And in this case, we want to find the mean of that variable highest year of school completed. Let's hit the play button. Okay, so we've got NAs again. So I'm going to stick in that drop NA function. And I want to drop NA on born in the US and on the highest year of school completed. So we'll do both of those. Control Enter here. Okay, so there are our means. And I could find the difference in means 12.7 minus 13.9, negative 1.2. So again, we observed a difference, but is it statistically significantly different? And to do this inference, we're going to use the t_test function. So this is very similar to, I think, last week, but now we have a response and an explanatory. The response is the thing that we're interested in, the numeric variable, the highest year of school completed. And the explanatory is the thing that we're going to break it up by to make two different means. So let's Control Enter here. Again, it is telling me that it's doing the order no and then yes, and I could specify that if I wanted to. So put comma in and then paste that in here, and now it's not going to give me that message. Okay, so I guess I did that two places here again. So for the hypothesis test, the thing that we're focusing on is the p-value. And we could think about our generic conclusion at the 5% level. And let's see, we have a very small p-value, so we reject the null because I'm going to copy it actually because it's a lot of zeros. This whole thing is less than 0.05. And then we have a generic conclusion at the 1% level. Again, we're going to reject the null because that number is less than 0. The 10% level. That's also less than 0.1, it's less than 0.01. So we would basically reject the null no matter what our alpha level was, unless it was really, really, really small. We're going to reject the null. And so then in context, we have evidence to suggest that the mean number of years of school completed is different between people born in the US and born outside the US. And I think that kind of makes sense, right? If you had to spend time in your life immigrating to the US, maybe you wouldn't have quite as much time to do schooling. So maybe that sort of agrees with what we might expect. So that was the hypothesis test. We also could do a confidence interval, and again, the code is basically the same. So I'm gonna copy this code up from up here, put it down here. I'm gonna take out that alternative part because I don't really need it. It wouldn't really complain, but I can take it out and hit play. And now instead of focusing on the p-value, we're gonna focus on the upper CI and lower CI. And so now how can we interpret that confidence interval? You could think about this for a second and then come back and see if you agree with my sentence. But I think I'm going to say I am 95% confident that the mean number of years of school completed by someone born outside the US is between 1.7 and 0.7 years lower than for people born in the US. So on average, it's lower, and we're 95% confident it's between 1.7 years lower and 0.7 years lower. So it's easier to write that sentence because it does not contain 0. And again, I don't think I asked this, but does that agree with the hypothesis test? Yes. We rejected the null, we said that we thought that there was a difference, and then we got this confidence interval that was pretty easy to interpret because it was all negative. So the last thing that I want to think about is about inference for paired data. So this only works if there's a natural pairing in your data. So probably in lecture you've heard about the ideas of twins, or like pre and post testing on the same individuals, but there's other ways that data could be naturally paired. So in R, there's lots of ways to do this. The easiest one is to make a variable that is the differences and then do inference on that one single variable. So some data sets will already come with a difference calculated for you, but sometimes you need to compute it yourself. In my data set, the GSS data set, I don't have anything that is already a difference, but I have some naturally paired data. So I have the highest year of school completed father and the highest year of school completed mother for an individual. So we're assuming that people have heterosexual parents, that there's like not divorce and stuff going on here, that there aren't single parents, right? So a lot of assumptions. But if we assume all those things, then the data is naturally paired. I could do the difference of your father's education and your mother's education, and that would give me a new variable that was a difference. So that's the thing that I'm going to do inference on here. So I want to know if the mean level of education is different between mothers and fathers. I could have done it as separate samples, so mother's education and then father's education. But instead what I'm going to do is I'm going to smoosh that together into one variable, the difference, and then I'm going to do inference on that. And in this case, that probably makes more sense to do the pairing because there's like ways that people pair up into romantic partnerships that might mean that, you know, higher education people end up together or maybe not. So we'll see how that goes. So in order to do this kind of inference, I have to make this new variable diff. So I'm going to mutate, which is going to give me a new variable in my data set. So right now, let's see, I have 2348 observations of 45 variables. And when I run this code, I'm going to have the same number of observations, but I'm going to have one more variable. So let's hit the play button here Yep, now I've got 46 variables. And my new variable gets tacked on to the very end. So let's scroll all the way over. So these people, this person, their education between their mother and their father, it was the same. Here, it looks like their mother had 8 years fewer of schooling, 4 years fewer of schooling, 4 more years of schooling. Just the same, just the same. We've got some NAs, etc. And now that we have that single variable, diff, we can do inference just like we would for a single mean. So we could start with finding the point estimate. And again, you could think about this from the quantitative variables lab and see if you could find that point estimate. You could pause the video, see if you could do it. And I'm going to do it. So I'm going to take the GSS data, and then I'm going to summarize, and I'm going to find the mean of that difference, DIFF. And I'm going to hit play. Oh, it says NA. So I need to stick a drop NA into my pipeline. I'm going to drop NA on the differences, and then I need another pipe at the end of this. So it's GSS, then drop NA of diff, then summarize the mean of the diff. Okay, and the mean of those differences is negative 0.00961. So that's pretty small. My guess is that's not going to be significant, but let's do the inference to find out. So what we're going to do is basically inference for a single mean, and I went and got some code from the inference for a single mean lab, and what I'd like you to do is see if you can modify it to do inference on our new variable. So again, I'd encourage you to pause the video and try it out and then come back. All right, so let's see. We need to change the response. Instead of number of hours worked last week, it's going to be my new variable diff. I think my alternative is two-sided. I want to know if that difference is equal to or not equal to 0. And then I need to put in mu equals 0 as my null mean. So if I hit play, okay, I get a p-value, I get a confidence interval, so I could either do a hypothesis test or a confidence interval here. So we needed to change the response variable. I think I left the alternative the same way, and the mu I needed to change. And what is our conclusion? So the hypothesis test, we do not have evidence to suggest that the difference in education levels is different than 0. And so in other words, it seems like mother's education and father's education is about the same. There's no significant difference there. And we could see that also from the confidence interval. We could say I'm 95% confident that it's between mothers being having 0.16 fewer years of schooling and mothers having 0.14 more years of schooling. And because that interval contains 0, it agrees with our not significant p-value, that big p-value. All right, so now I think you have the code that you need to do the real lab. And as always, ask me if you have any questions.